Viktor Lavrov, Deputy Managing Director from Innoter company in Russia. He will speak about the use of CFS PHOTOMOD in geological projects of the company Innoter.
Dear colleagues, for many years, since 2012, since Canopus V has been launched, I mostly reported on the operation of Russian-made satellites, but I'm going to break out of this habit and offer a different subject. I'll explain why later. In the context of a crisis and market narrowing down, Innoter sought other applications. Even though remote sensing in geology is not Innoter's know-how, it's been around since Soviet times, but we have found this niche, and the number of projects has numbered dozens in the field of geology, driving the need to open up a separate division in my company dedicated to, of course, we are not professional geologists. Therefore, what we offer is a DSM creation, spectral structuring, and a thematic processing. And we execute all of that in the form of a topographic base and GIS. Our experience showed that the usage of remote sensing techniques enhances efficiency of geological projects. The advantages and the causes for that are explained here. One of the clearest factors at the time of crisis is the economic factor, the money factor. Drilling has always been the most expensive thing, and geologists try to bring down the price as much as possible for empty drilling. And remote sensing scale up performance and efficiency of drilling, cutting down on unnecessary drilling. So this has informed our cost efficiency a lot. Remote sensing techniques are developing all the time. Here's what we found on Worldview 3 by Digital. You know that they operate a SWIR band. So the top left slide shows you the schematic of the golden band, as it is called. Russia, as you can see, is the white spot in this regard, although the foreign companies heavily use it, even though the geological structure of Alaska and the northeastern part of Russia are completely identical. We know about the gold rush. I guess our gold rush is still ahead if we use the right technology. So here's what we did. I will walk you through some of the most significant projects that we did. This is the gold-bearing deposit on Kamchatka. We commissioned Digital Globe to produce a survey with the 0.3 meter resolution at certain angles. We created ortho photos initially. These are the block adjustment parameters. With your permission, I will not read out the numbers unless you ask me separately. So highly accurate EM was generated, and based on that, 1 to 5,000 topographic maps were generated. Then the digital elevation model of Ozernova geological grounds have been established. The owner of this gold mine, the Siberian mountain company, wanted to sell it off, but once they came by this data, actually they have their own field team, so they decided otherwise, not to sell it, but rather build a mining complex. So it appears that this data has helped them make the right decision, which is another benefit of the remote sensing data. Even though no thematic processing was used, simply based on geometric parameters. Another important project is with Lavrov. I should give them the credit. They do annual projects, but they're all the same, and it's always the same routine. I mean, survey and orthophoto plan, survey and another orthophoto plan. For the first time, we used SWIR band from Worldview 3. You know, they have the atmospheric correction band, which I'm going to show. We used a blue ground field and two other sites with various degree of data, varying degree of data availability. You may be aware about this cluster of sites. The Sundukari site has just had utility lines put in the ground. So it's a standard photogrammetric processing procedure. We used a Ferranti digital model for Sundukari section. Ortho transformation, stitching into high accuracy mosaic, triangulation model of the terrain. This is Mirnina blue ground field information. A digital surface model was built. This is DSM for Sundukari. In this project, not only photogrammetric processing was used, but also thematic processing. Multi-zonal composites were analyzed. Visual interpretation has been conducted. And then we show the full cycle of operations. First, primary processing, which included radiometric processing, among other things. Calibration, matching separate channels and channel groups. into one composite. Atmospheric correction. As we know, Worldview 3 provides atmospheric correction band, but Digital Globe has turned it into a separate service, and they are able of performing atmospheric correction for any project. You can request that from them, even when Russian surveying is performed. This is a radiometric calibration where pixel brightness values were converted into physical units. This is an example of atmospheric correction where spectral response has been adjusted for. Getting slightly ahead of myself, the complexity, the challenge was that it was difficult to use remote sensing data. But in order to find the piping, I mean, there was an issue with sedimentary mantle. It was difficult to determine the gold-bearing capability. This is a Nuremberg pipe or tube showing how challenging it was to find the right information. This is mineral index diagram. You saw this one. Now, describing the full cycle. Pseudo-illumination modeling. Establishment of reference materials. We created atlases of materials of space imaging and derivatives. Also, we are confident that remote sensing data does not provide you with 100% reliability, but it significantly improves the efficiency of geological projects and the high probability of prospecting, successful prospecting. This is as far as the Russian projects are concerned. We also did a couple of projects on the foreign ground in Tanzania, and we've located a gold-bearing mine in Tanzania. Thank you. Your questions? A very informative presentation. If you would go back to the DSM creation slide, what technology was utilized? In all cases, we used the highest resolution available, 0.3 meters, 30 centimeters, that Digital Globe provides from Worldview 3 and Worldview 4. So we put together a stereo pair, and in consultation with the miners, geologists, we calculated precise angles of surveying. So it wasn't extracted from the archive. We commissioned this survey. And based on that, we generated a digital surface model. How long did it take to do a stereo I mean, digital survey. You know, this is a specific place, Kamchatka. We had a window of opportunity 2 weeks later. This deposit is located next to military base, Kura. So perhaps that window of opportunity or cloudless skies were created thanks to some exercises, perhaps military exercises. Just a fluke of luck. Initially, plans were created as panoramas, even though geologists, local geologists, used AutoCAD. The assigned value was 1 to 5,000, but they asked for a contour for spacing of 5 meters. Thank you. Any other questions? Doesn't seem to be the case. Let's thank Victor once again.